Causal reasoning is a way we can evaluate several possible explanations to determine which explanation best accounts for the outcome. Often people want to make an argument about why something has happened or whether something is likely to happen. In order to make that kind of an argument, it is necessary to say something about what has caused or is likely to cause a given event or outcome. Being able to establish what caused what allows people to make many different types of arguments. First, by using causal connections, we can offer explanations of events or outcomes that have occurred. That is, we can answer the question, why did X happen? Second, causal connections can help us make predictions. If we've determined that, at least generally, X causes Y, that is, when X is in place, Y is likely to happen, then we can predict future instances of Y. Finally, establishing causal connections allows us to determine who or what is responsible for a particular event or outcome. Assigning responsibility is important for many reasons. One reason is that if we identify something as a problem that we'd like to address, knowing who or what caused the problem is necessary for dealing with it. If you decide that you want to make sure B never happens again, it's essential to figure out what caused B to happen in the first place. There are some key things to keep in mind as you engage in causal reasoning or evaluating the reasoning of others. First, you should be aware of a crucial distinction between correlation and causation. Put simply, correlation occurs when two things tend to happen together. It refers to an association or relationship between the two things. When someone says that A and B are correlated, that means there's some kind of connection between A and B. Perhaps a person who conducted data analysis found that when A was high, B was also high, or that when A decreased, B also decreased. But note that establishing correlations does not say anything about causation. Causation refers to a specific kind of relationship in which one thing is the reason another thing happened. Causation goes beyond simply saying that A and B are related or correlated. It's much more important to critical thinking to claim causality, such as A causes B. For example, consider two aspects of a class that can be measured: grades and attendance. A professor might keep track of attendance throughout the semester, along with, of course, tracking the students' grades. At the end of the semester, he looks at a spreadsheet and notices that students who have high attendance scores also have high grades, whereas students who have attended class infrequently have low grades. He might conclude that attendance and grades are correlated. That is, there's a relationship between attendance and grades. However, based solely on this single premise, when attendance is high, grades are high, and vice versa, he cannot make the argument that regular attendance causes higher grades. The fact that these two factors vary together, when one is high, the other's high, when one's low, the other's low, is not enough to establish a causal relationship between them. One causes the other. The professor would need additional evidence to justify a causal claim about the relationship between attendance and grades. In addition to recognizing the difference between correlation, there's an association, and causation, the association is such that A causes B, you should also recognize that causal relationships involve time and location. Generally, causality involves events that are close in time and location, but that's not always the case. One of the reasons why engaging in causal reasoning in order to make an argument about causation is so difficult is that causes can occur long before and or far away from their effects. Another complicating factor is that many events and outcomes can have both direct and indirect causes. A causes B, which causes C, and so on. A direct cause is the event closest in time and or space to the outcome you're trying to explain. Indirect causes are those things that preceded the direct cause and in some way contribute to the chain of events leading to the final outcome you're concerned with. Take, for example, a large forest fire. The direct cause might have been a lightning strike that hit one tree, causing it to catch on fire. But there may be indirect causes that made that area of forest more susceptible for fire, such that a single tree catching on fire resulted in a very widespread forest fire. Maybe the area had been experiencing a drought, so the trees and undergrowth are really dry. Another important distinction is between necessary causes and sufficient causes. You've already learned about the difference between necessary and sufficient premises. The same distinction applies to causes. A necessary cause is a condition that must exist in order for a certain effect to occur. If A doesn't happen, then B can't happen. A sufficient cause is one that is enough for the effect to occur. A alone is required in order for B to happen. For most complex problems, it's unlikely that any one cause will be sufficient. There are two main ways that causal arguments are used. First, they are put forth in order to explain a specific event, outcome, or phenomenon. The 2008 economic crisis is just one example of the broad range of social, economic, political, and cultural events that people seek explanations for. Causal reasoning can help us wrestle with different possible explanations to figure out which one seems to best account for the outcome. Causal relationships can help us explain how events are related, but we also want to be able to make predictions and plan for the future. Understanding why the 2008 crisis occurred is useful, but it's especially useful if we can take that explanation and use it to try to prevent such a crisis from occurring again. Causal arguments allow us to understand the relationship between various factors and use that understanding to develop plans and policies to either cause a specific outcome or prevent an outcome. If we can make predictions based on our knowledge of what has happened in the past and why, then we can predict when it'll happen again or change our behavior so that it doesn't happen again. These plans and predictions are only as strong as the causal explanations on which they're based. Causal reasoning is an effective tool for critical thinking. Not only can we say that two events occurred together, we can explain why.